Hello guys, welcome to my channel Toppers Classes Ara. In last videos we have discussed Euclid division lemma and the method of finding HCF by Euclid division lemma. Now in this video we will learn fundamental theorem of arithmetic. This is a very simple theorem. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factor occur. What it is saying? Every composite number can be expressed as a product of primes. This is the important. Means any composite number can be expressed as a product of prime, and this factorization is unique. Unique means it will be only one type. For any number it will be unique apart from the order in which the prime factor occur. Order doesn't matter. Anyone will be left, anyone will be right. Okay, so I will explain it by one example, then it will be very clear. Suppose one number is given 140. Okay, so take the prime factorization. As all of you know, 2 7 ja 235, 5 7 ja 7 1 ja. 140 is a composite number. So what is the prime factor? 2 into 2 into 5 into 7. So this factor is unique. This factor is only for 140. It will not be a factor for any other number. It is saying unique means the prime factor of any composite number will be unique. Like for 140 it is 2 into 2 into 5 into 7. It is unique for 140 only. It will not apply for any other number. And what it is saying? Order does not matter. Order does not matter means we can write it as 5 into 7 into 2 into 2. Means we can shift the factor left or right or anywhere in between. Okay, so order does not matter. This is the fundamental theorem of arithmetic. It is very simple, I think. Now on this basis, on prime factorization, on fundamental theorem of arithmetic, exercise 1.2 of NCERT is totally based on this theorem. Okay, so we will solve the exercise 1.2, then it will be very clear. Okay, now bringing 1.2, just 1 second. Question number 1. Yes, what is question number 1? Question number 1 is saying express each number as a product of its prime factor. I think this thing you have studied in class 7th, 8th and 9th. Okay, so this is very simple. First question is 140. As I have discussed already how we calculate the prime factor. Okay, so just take here 2 70, 2 35, 5 7 ja 7 1 ja. We have to express each number as product of its prime factor. Okay, so 140 can be written as, here 2 is 2 times. Okay, so we can write it as 2 to the power 2, 5 is 1 time, so 5, 7 is 1 time, so 7. This is the required answer. Similarly we can solve to 156. Just 2 7 ja 1 6 16, 2 8 ja 2 3 ja 2 9 ja 3 13 ja 13 1 ja. So what is prime factor of 156? We have to show like this: 2 to the power 2 into 3 into 13. This is the required answer. Okay, similarly you can do all the others. Just you have to find the prime factors. Okay, if you have any doubt in anyone you can ask. Okay, now coming to question number 2. Question number 2, just 1 second. Yes, this is question number 2. No, it contains 3. Just 1 second. Yes, it is question number 2. Find the LCM and HCF of the following pair of integers and verify that LCM into HCF equal to product of two numbers. Okay, so we have to find LCM and HCF. So first question is given 26 and 91. Just 1 second. One question I am showing. Okay, 26 and 91. These two numbers are given. We have to find the LCM and HCF. Okay, LCM and HCF we have to find. Then we have to show LCM into HCF equal to product of two numbers. Product of given two numbers. Okay, two numbers. Just 1 second. I have to erase. Product of two numbers. Now we have to find HCF and LCM, but it is not mentioned how we have to find. There are two methods to find HCF and LCM. One by prime factorization method and other by just taking division. So in this question we are studying fundamental theorem of arithmetic, so we will apply the prime factorization method. Okay, so just do the prime factorization of 26. So take just 1 second, sorry, I have to take 26. Okay, so 26, now 2, 13, 13, 1. So prime factorization of 26 is 2 into 13. Now what is 91? Take 7, 13, 13, 1. So we can write 91 as 7 into 13. So what is the HCF here? HCF is the common between prime factors. So what is common here? 13. Okay, the HCF is 13. What is LCM? In LCM we take the common part. So what is common? 13, and the other factors which are not common we have to take that also. So we can take 2 and 7. So what is the answer? 13 into 14. So what it is coming? 13 4 ja 52. 13 1 13, 182. Okay, now we have to verify this. We got LCM and HCF. So put here LCM and HCF, and product of numbers is 26 and 91. Both should come equal. So HCF is 13 and LCM is 182. Just 1 second. So we have to verify LCM into HCF equal to product of numbers. Product of numbers. Okay, so what is LCM? LCM we got 182 and HCF we got 13. Now what is the product? 26 into 91. So check here, 13 2 ja 26, 13 8 ja 104, 106, because carry was 2. Now carry is 10. 13 1 ja 13, 10, 23. Now multiply this. 26 1 ja 26, carry 2, 26 9 ja 26 9 ja 9 2 ja 18 5 2 3, 26 9 ja 2 3 4, and carry is 2, so it will be 2 3 6. So you can see LHS and RHS both are same, 2366. So in each question, in question number 2, in all sub part you have to do like this. This is the whole process. Just find HCF and LCM by prime factorization, and then you have to verify also by multiplying the LCM and HCF and by multiplying the both numbers. The product of LCM and HCF should come equal to the product of both numbers. Okay, this is the very simple thing. So in question number 2 and 3, in sub part you have to do this. Okay, now coming to question number 3, I am leaving question number 2 sub part 2 and 3 okay for you. If you have any doubt, you can ask in comment section. If you are getting difficulty in solving sub part 2 and 3, then you can ask me, I will definitely solve. Now coming to question number 3 part 1. Question number 3 part 1, just one second, I am bringing the question. Question number 3, this is the question number 3. Yes, it is saying find the LCM and HCF of the following integers by applying the prime factorization method. It is clearly saying by applying the prime factorization method. What is the first question? 12, 15 and 21. We have to find the LCM and HCF by prime factorization method. So simple. First of all, find the prime factors. So what is prime factor? 2 6 ja, 2 3 ja, 3 1 ja. Okay, similarly for 15, 3 5 ja, 5 1 ja. Similarly for 21, 3 7 ja, 7 1 ja. Now write all the prime factors here. 12 can be written as 2 to the power 2 into 3. 15 can be written as 3 into 5, and 21 can be written as 3 into 7. So what is the HCF? HCF is common, all the common factors. So HCF we can write, what is common here? The common factor in all the 3 is 3. This 3 I have rounded, so it is 3. Now coming to LCM part, what is LCM? As I told you, LCM is just take the common part along with which is not common. So not common is 2 to the power 2 means 4, and also 5 and also 7. So what is LCM? 3 4 is 12, 12 5 is 60, 60 into 7, 420. So this is the LCM and this is the HCF. Just you have to do these things. Now in sub part 2 and 3 you can do, there are very small numbers, and if you have any doubt you can ask in comment section. Okay, now one more question, question number 4. I will show you question number 4, just one second. Yes, question number 4 5 6. Okay, so what is question number 4? Given HCF, written HCF 306, 657. HCF of these two numbers is given 9. We have to find LCM of these two numbers, 306, 657. Okay, HCF of these two numbers 306 and 657 is given 9. You have to find the LCM of 306 and 657. Okay, so many of a student think they just start prime factorization of 306 and 657 and they can find the LCM, but that is a very long process. So just here apply the formula. The formula comes from here. HCF into LCM equal to product of numbers. So just from here we can find what is find, where to have to find LCM. So you have to find LCM. So take LCM from here. Send the HCF on the RHS side. So product of numbers divided by HCF. So just put the values here. Product of numbers means just multiply 306 and 657. And what is divided by HCF? So what is HCF? HCF is given 9. So just 9 7 ja 63, 2 2 7 27, 9 3 ja 27. Now what is the LCM? 306 into 73. Okay, this is the LCM. Just we have to multiply 306 and 73. Okay, this is not the point. Okay, by mistake. So 306 and 73 we have to multiply. That is the answer. So 306 and 73. 6 3 ja 18, 1 0 3 ja 0, 1 3 7 ja 3 3 ja 9, 7 6 ja 42, 0 7 0 4, 7 3 ja 21, 8 3 13, 1 1 2 2. So what we got LCM? 22338. This is the required answer. Okay, so you have to apply the formula. If it is asking find LCM, then put the HCF in denominator, and if it is asking find HCF, then put the LCM in denominator. I am writing both the formula for your convenience. Suppose it is asking LCM, then product of numbers should be in numerator. Product of numbers divided by HCF, and if it is asking HCF, then product of number will be as above of numbers divided by LCM. Okay, but remember this thing, this formula will be applicable only if two numbers are given. I am writing, it is very important note. This formula is applicable only if two numbers are given. Two numbers are given. This formula will not be applicable for 3 or 4 numbers. Okay, if it is asking find LCM and HCF of 2 or 3 or 4 numbers, then this formula will not be applicable. This formula is applicable only for 2 numbers. Okay, if it is given 3 or 4 numbers, then do not apply this formula. Okay, this formula is applicable only for 2 given numbers. Okay, now there is question number 5. Just 1 second. No, this is not the question. This is also not the question. Just 1 second. Yes, question number 5 is saying check whether 6 to the power n can end with the digit 0 for any natural number n. Means saying 6 to the power n end with the digit 0 for any natural number n. So we have to check whether 6 to the power n end with 0, where n is any natural number. Like this, suppose n we take 1, so it is 6, it is not ending with 0. Suppose we take 2, it is 36, it is not ending with 0. 6 to the power 3, it is 216, it is not ending with 0. Okay, so in this question it is saying check whether it is ending with 0 or not for any natural number. N can be 10, 12, 13, 17, n can be any natural number. So in each case we do not apply. Suppose this was 6 to the power 2, 6 to the power 3, so we can apply multiplication. But if it is asking we can take n as 30, then it will be very difficult to multiply 6 30 times. Okay, so we do not do question like this. Okay, so we will apply a very simple method. It is asking we have to check whether it is ending with 0 or not. Okay, so for ending with 0, what we have to do, if any number is ending with 0, then it contain 5 and 2 as a prime factor. Suppose 20 is given, 20 is ending with 0, so we can check the prime factor of 20. What is the prime factor? 2 10 ja, 2 5 ja. Okay, so what are the factors? 2 and 5. Okay, so for any number ending with 0, in prime factor of that number there should be at least 1, I am writing here, at least 1, 5 and 1, 2, because when there will be 5 and 2, then 5 and 2 will multiply, it will give 10, so that number will end with 0. Okay, so for the prime factorization of any number there should be 2 and 5, then that number will end with 0. Okay, so we have to here it is asked we have to check 6 to the power n whether it is ending with 0 or not. So we have to check the prime factor of 6 to the power n. So what can be the prime factor? So 6 we can write as a prime factor 2 into 3 and power is n, so we can write 6 to the power n as 2 into 3 to the power n. Now we can separate each term, so we can write it 2 to the power n and 3 to the power n. So n is any natural number. Suppose we are taking n as 5, so it will be 2 to the power 5 and 3 to the power 5. Suppose we are taking n as 6, so it will be 2 to the power 6 and 3 to the power 6. So by looking it, 5 is not looking here. Okay, 2 is looking, but 5 is not looking in the prime factorization of 6 to the power n. So for ending with 0, as I already told, there should be at least 1 2 and 1 5, because both will multiply, then it will give 1 0. Okay, so in the prime factorization of 6 to the power n there is only 2, 5 is absent, 5 is not here, so it will not end with 0. So what we will write the reason? We will write the reason like this: it is not ending with 0, it is not ending with 0. Okay, and also it is not the reason I will write now, because for any number ending with 0, it is very important question. Okay, for any number ending with 0, and concept is also important, for any number ending with 0 there should be at least 1 5 and 1 2 in the prime factorization of that number. So for any number ending with 0 there should be at least 1 5 and 1 2, means both 5 and 2 should be present. There should be at least 1 5 and 1 2 in the prime factorization of that number. But here in the prime factorization of of 6 to the power n, there is only 2 and 3 is present. So 6 to the power n does not end with 0. 6 to the power n cannot end with 0 for any natural number n. Any natural number n. This is the whole expression. Natural number n. This is the whole explanation for this question. Okay. The main thing is that for any number ending with 0, there should be at least 1, 2 and 1, 5 in the prime factorization. This is the main reason. But here we saw there is only 2 and 3 in the prime factorization of 6 to the power n. So this number cannot end with 0. Okay. This is the main reason. Now one more question I will explain, then I will explain the last question in next video. Okay. Now coming to question number 6. 6 question number. Yes. Question number 6 is saying explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. It is saying explain why these given two numbers are composite numbers. So first of all we should know the definition of composite number. What is definition of composite number? Composite number means there should be at least 3 factors, because each number have at least 2 factors. Suppose any prime number is 7. Suppose prime number is 7, it has 1 and 7 as factor. So 1 is factor of each number and that number is also a factor of itself. Suppose 13 is a prime number, so it has 1 and 13 as prime factor. So 1 as 13 as factor. Okay. So for any prime number there is 2 factor. Okay. One factor is 1 and other factor is number itself. Okay. So for prime number there is 2 factor. So for composite number there should be at least 3 factors, means more than 2 factor. So this is the definition of composite number. So smallest composite number is 4, because it has 1 as factor, 2 as factor, 4 as factor. 2 is not a composite number because it has 1 and 2 as factor. 3 is not a composite number because it has 1 and 3 as factor. So many times it is asked in questions objective, which is the smallest composite number. So remember, smallest composite number is 4 because it has 1, 2 as 4, 1, 2 and 4 as factor. Okay. Smallest composite number is 4 because it has 3 factors. So for a number to be composite, it should have at least 3 factors. Okay. So now we will explain this question. Okay. Just 1 second. Yes. So first part I am explaining. 7 into 11 into 13 plus 13. It is asking explain whether it is a composite or not. So for composite there should be at least 3 factors. So we have to show whether this number has 3 factor or not. Okay. So 13 is there, just take 13 as common. Just 1 second, it is disturbing. I have to erase that part. Okay, just 1 second. So take 13 as common. Okay, 13 as common. So 7 into 11 left here plus 1 will be here. Now 13, 7 into 11 it will be 77 plus 1. So it will be 13 into 78. Now it is looking only 2 factor, but we can write it as also 13 into 78 into 1. Okay, 13 into 78 into 1. So it has 13, 78 and 1 as factors. So it is a composite number. It is a composite number. It is a composite number. Now coming to second part. It is given 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Take 5 as common. So it will be 7 into 6 into 4 into 3 into 2 into 1 plus, we have taken 5 as common, so here 1 will left. Okay. Now 5 we can multiply 1 into 2 into 3 into 4 into 6 into 7. Okay, so 7 into 6 is 42. Okay, minus, it is looking at minus, so don't confuse, it is not minus. So we can write it as 7 into 6 42 and 4 into 3 12 into 2 24 plus 1. We can write it as 5 into 24 2 ja 48, carry 4, 24 4 ja 96 or 400 plus 1. So it will be 5 into 1009. We can write it as 1 also here. So what is the factors? It has 5, 1009 and 1 as factors. So it is a composite number. So it is a composite number. It is a composite number. Just it. Okay. So we have explained exercise 1.2, finding LCM and HCF by prime factorization method and verifying LCM into HCF equal to product of two numbers. So please like, share and subscribe my channel, and if you have any doubt, any confusion, you can comment. I will sure reply. Okay. So thank you everyone. Please like, share and subscribe my channel. Thank you.